Hi, everyone. First of all, I'd like to thank you for being connected in the macro 3 section. The first paper, the macroeconomic effects of sovereign wealth funds in small open economies, will not be presented because the author will not attend this session. So I divide the time between Fernando and me. Fernando will present first the paper Inequality and Growth in an Applied Dynamic General Equilibrium Model with Heterogeneous Agents and Progressive Taxation of Capital Income. I just review the instructions for the talk. If possible, leave the questions to the end of presentation. However, if you have a clarifying question, just unmute yourself during the talk and ask. Fernando, you have 35 minutes to present, and we will leave 10 minutes for questions at the end. I will tell you when there are 5 minutes left. So the floor is yours. Thank you for presenting today.
Hi guys, thank you everyone for being here. Let me ask if you mind if I run this presentation in Portuguese. I think everyone here is speaking Portuguese, right? I don't know what you guys prefer, so I'll follow the presentation in English. It's better. Let me share my screen here. So guys, I will present here a paper that deals with the inequality and growth in applied dynamic and general equilibrium model with heterogeneous agents and progressive taxation of capital income. In fact, we present two models here. One of them treats the source of income separately, and the other model tax the total income of the individual with progressive taxation. This paper is part of my PhD thesis, so let's go. Our paper is part of a body of works that deals with the interaction between economic growth and inequality, income inequality. A lot of works that deals with this problem assess this issue by using models that treats the taxation as flat rates. But what we see in practice is that a lot of advanced economies use progressive taxation, at least in some degree. So recently, a lot of works are dealing with the progressive taxation to assess this issue of the interaction between economic growth and income inequality, as well as existence of a trade-off between these two measures. So also this progressive taxation is an issue that getting a lot of attention recently due to the evidence that the income inequality is increasing in the past decades. So in both political and economic scope, the subject is very hot. So it makes sense to the economists to try to model the progressive taxation and assess quantitatively the results of a policy that increases or decreases taxation in order to achieve a more equal income distribution. The dynamic general equilibrium models are an interesting tool to analyze this issue, and we are following this approach, which is widely used in this proposal. Our paper uses this methodology, and we are also contribute to the literature by showing the dynamic response of a fiscal reform, observing the response of each quintile of income. So we are present in the dynamic evolution, dynamic response of each quintile to fiscal reform. In fact, there is a paper of of Lee and Sartre that already does this, but they only show the results in the steady state, not the dynamic transition. So we are contributing to the literature by showing dynamic transition of each quintile in response of a fiscal reform that increases the progressivity. The review of the literature can be divided into two strands. One of them treats the markets as incomplete markets. In this assumption, the progressivity deals, actually the progressivity works like an insurance to the productivity shocks that the agents are susceptible. But we follow this strand here, which is the model of complete markets. In fact, we are following straight the Konyuk and Chernovsky basic methodology and notation, but we are propose here two main extensions of their model. The first extension is to consider the source of the heterogeneity as the intertemporal elasticity of the substitution. It means that the agents have different intertemporal elasticity of the substitution, which is not the conventional way to model the heterogeneity. Actually, since Becker in the 80s, he proposed the heterogeneity as the differential rates of discount. And this approach is followed by Liansart, Konyuko, and Chernovsky, and Chen. But it's not a real effective. Carrie Young, for example, used the heterogeneity as a productivity difference between the individuals. We are here using the differences in the intertemporal elasticity of the substitution, an issue that's not often used in the literature, in spite of the fact that the evidence, the empirical evidence assure that there is a lot of heterogeneity in this parameter. The intuition behind this is that the poor guys have more difficult to smooth their consumption over the time, since their consumption is basically composed by basic subsistence goods. So it's very difficult to reallocate these over the time. And also because they don't have access to the financial markets, or at least have restricted access. So the variations in the interest rates doesn't affect their consumption. So we have evidence that the richer guys have higher intertemporal analysis of the substitution. The second stance to propose here is to treat the source of income separately in the taxation. It means that we use a separate tax scheme for the source, for income source from capital income and from labor income. This is basically what Shem does too. She also uses this. But here in this model, we are proposing a flat rate in the labor income and a progressive taxation in capital income. And we show further that we run two numerical simulations where we propose a fiscal reform that changes the taxation in the model to focus the progressivity only in the capital income. Let's describe the model. The production technology is a Rummer type production technology, whereas the output is a Cobb-Douglas combination of two factors, is labor and capital. The labor here is measured as in efficient units of production. As you can see here, this production function is capable to sustain the endogenous growth, as it has constant returns of scale between labor and capital, and also between two capitals here, the augmentation factor and the capital. Assuming that the firms are identical, we have this AK production function. It's very simple. And the factor price of the equilibrium price of the factors are the marginal productivity, and it's expressed in terms of the leisure here. The households are, as you had told, they are indexed by I. there are n individuals. In our model, we are using n equal to 5 because we're observing the quintiles. They are identical in all respects, but they have different endowments of capital and also different elasticity of the substitution. They maximize this isoelastic utility function in terms of their consumption and leisure. Their gross income is a result of the income from capital and income from labor. Just getting back here because I didn't speak too much about this. The labor here can be interpreted as raw labor, and the capital is an amalgam of capital, physical and human capital. So the returns to labor does not include the skill labor. So the returns for new capital are included in the returns of capital here. Okay, this is important because when you see the numerical simulation, you will see the richer guys offered a very low dotation of time, a very low labor supply, but in fact they are offering very low labor of raw labor supply. So it makes sense. In this economy, the tax schedule is divided in the taxation on labor income, which is flat. It's equal for all the individuals. And the tax on capital income is progressive. As you can see here, this is the basic tax rates, this zeta here. The fee is a degree of the progressivity. The taxation is a function of the relative capital stock of each agent. As you can see here, if the agent has a portion of capital that is larger than the average capital, this will be more than 1. So they will be taxed in a rate that is higher than the average rates. And as you can see here, if the progressivity degree is equal to 0, the tax is flat, so it's equal to the base tax rates here. If the fee is higher than 1, it means that the taxation increase by increasing rates. So if it's less than 1, it's increased by decreasing rates. The tax on marginal capital income is the same taxation multiplied by the capital and derivated by the capital. So the budget constraint of this agent is expressed by this equation here, which is the capital accumulation over the time, his net income of capital, net income of labor, his consumption. Here the aggregates rules of income and capital and leisure. It's important to see that we are working with distributions in this model. We're not working with levels. So when we see the numerical examples, we have to have this in mind, to bear this in mind to understand the results. So we are observing the shares, the portions of each agent on capital and on income. The government here has a balanced budget. It doesn't issue public bonds. Its expenditures is equal to the revenues. So it's basically the government's consumption. It doesn't affect the production or the utility. These are the individuals' growth rates of capital and also the aggregates growth rate of capital. That's in the long run steady state. This is equal to the growth of this economy. In the long run, all agents converge to a common growth rate, which means that at the long run, this is equal to this one. So let's see how the model provides a non-degenerate distribution of income, consider a progressive tax and the heterogeneity. Suppose that we have 2 agents in this model, and the agent EI has a higher intertemporal elasticity of substitution than the household J. This means that in the steady state, they have a common growth rate. And as this is smaller than this one, we conclude that this is greater than this. And in the steady state, the individual with the higher willingness to substitute future for present consumption will end up owning a larger portion of the capital. The alternate model, we are present until now the model with that treats separately the source of income to tax. But in this alternate model, we work in the framework that treats both source income as just one, and the progressivity tax all the income of the individual. The main difference is on the budget constraint of the individual. Now we have just one tax rate, and this tax rate is a function of the relative income of this individual. As you can see further, this tax rate is less progressive than the tax rate present earlier, since the income distribution is more equal than the capital distribution. So this here is smaller than the other assumption in the case of the Eat Your Guys. So it's quite less progressive, this taxation, than the other one. So in this model, we follow Turnovsky and Konyuku, basically, but we preserve the source of the heterogeneity as the intertemporality of the substitution. Well, the calibration of the model, we use a conventional calibration because in this model here, in this paper, we are not looking for a policy that actually was implemented in any country. Instead of this, we are looking for compared to fiscal reforms. So it wouldn't be necessary to calibrate this in a sense to reproduce an economy like Brazil and the United States. So we follow a conventional approach and use the conventional parameters that are used in the literature. We set the average value of the intertemporality of the substitution as 0.5, which is the same value that you are using by Lucas, Bayer and Bloom, Turnovsky and Konyuku, and a lot of other papers. So this means that the intertemporality of the substitution of the third quintile is equal to 0.5. And we use this arbitrary condition to separate them, which means that each quintile has a differential of gamma of 0.125 of the subsequent quintile. As I mentioned before, it's a conventional calibration, not too fancy, but it's very plausible to what you are looking for in this model. The policy and technology parameters follows the conventional also, and we have average tax rates on total income that equals to 12.1%, which is very similar to the average tax rates on individual income in the United States. Also, the degree of progressivity here is set as 0.75, which is the same as Turnovsky and Konyuku, and also Lee and Sartre. Okay, let's go. So this is the initial steady-state equilibrium. In the original paper, we showed two steady-state equilibriums, one for the main model, another for the alternate model. But here's the presentation as we have a limited time. We are just showing the steady-state equilibrium of the alternate model. So as you can see here, the aggregate growth rate of the capital is 2.23. It's very similar to the OECD country or United States economy. shall move on, guys? Are you listening to me?
Yes.
Okay. So as you can see here, the relative capital of all income quintiles gives us a distribution of capital that's quite, that's not too much similar of the we observe in practice. But as you can see here, the first quintile owns 0.09, which means that divided by 5, they own like 2% of the capital of this economy. And consider their income, they own like 12% of the total income of this economy. This capital distribution is very similar to what was observed of the first quintile. Sorry, it's very similar to what was observed in the empirical evidence showed by Rob Davis, at least for some countries. But yeah, it's quite more equal than in the real world. So we have to bear this in mind. So we are presenting here two numerical examples. The first one is the scenario A, where we depart from the benchmark economy and zero the progressivity of the labor income taxes. So we apply a flat rate in the labor income, and we increase the progressivity in the capital income. So, and this increase of progressivity came for two channels. The first channel is the increasing in fee by 50%. And the other channel is because this tax is considered the relative share of capital, which is more unequal than the relative share of income. In this model, in this simulation, we keep the tax burden constant through the time, which means that the government doesn't change its participation. And we have to adjust the base tax to keep the tax burden constant. These are the impacts and long-run effects of this scenario, this fiscal reform. Which one can say that is very severe, very drastic, and I agree with that. If you're increasing the progressivity 50% is fiscal policy that's quite aggressive. But let's go. So the impact in the economic growth, each quintile shows that to the aggregate economy, the impact is quite negligible, and there's no significance in this impact. Like the economic growth is stable in the short run. The effect is quite negative to the highest quintile, the richest guys, richest households, sorry. And to the fourth quintile is also negative, but it's positive for all the other quintiles, especially to the first one, the poorest households. They increase the substantial accumulation of capital. In the longer run, the economy will face a fall in its output growth by 0.12 percentage points, which means that if you are growing by 2.23 in the steady state, now we are growing by 2.12, for example. The effects on the distribution of income is quite insignificant in the short run on impact, but are quite powerful in the long run, as you can see here. The lowest quintile increases a lot of his share of income, while the highest quintile decreased a lot of his share of income, portion of income. And the same as in capital, also, there is a drastic reduction of the capital portion that the highest quintile owns, and a very drastic increase in the capital portion of the poorest households. So exposing these in graphics. These are the effects, the transitional paths. As you can see here, the effects in the income on impact are insignificant, but they are quite strong in the long run. The supply of labor of the highest quintile increased a lot in the long run, and the two poorest quintiles increased their leisure in the long run. The effects on taxation is quite diverse to the quintiles. As you can see here, the taxation of capital income of the poorest quintile decreased a lot, while it increased substantially to the highest quintile. And also the impact on the growth rate of capital in the lowest quintile is very high. They increased from 2.25%. Summarizing the effects here, we see that the effects on the taxation is quite diverse among the quintiles. For example, to the highest quintile, they increase their taxation of capital income, but they decrease the taxation of labor income. And to the poorest quintile, for example, they decrease a lot their taxation of capital income, but also increase the taxation on labor income. You also saw that this fiscal reform leads to powerful effects and does not affect the long run severely. And also that the switching from the progressivity to flat tax rates on the labor income leads to increase in the labor supply, which is in consonance with the literature. And also the distributional effects in the net income after taxes income are negative only to the highest quintile, which means that this policy has a good effect in terms of the distribution. In this scenario B is basically we follow the alternates model and increase the progressivity of the total income by 50%. As you can see here, in this case, the effect in the economy is negative in the impact, and it's also more negative than the other scenario in the long run. The economic growth decreased by 0.32%, which means that if we're growing by 2.23%, now we'll grow by 1.9 or something. And also the redistributive effects are not so drastic and as the other scenario. Here the aggregate growth of capital, the individual growth capital of the lowest quintile is 3.49%, which means that they are accumulating capital by a rate of 2.23, and now they are accumulating at a tax like 5.7, for example. As you can see here, also the effects on the income on impact are quite larger than the other scenario, which means that this policy has a more positive effect in terms of redistribution impact in the short run, but in the long run the effects are milder than the other scenario. It's also happened in the capital distribution. So this is the graphic of this dynamic response. As you can see here, the effects on impact by the distribution on the distribution of income is significant in this policy, but are not that significant in the case of the growth of rate of capital. In the other scenario, the lowest quintile increased it by 12%. Now it's 6% or so. Well, comparing these two scenarios, it's plausible because we're departing for the same benchmark economy. We use the same calibration, And in both models, we are using the tax burden as constant during the time. Also, we can see that the scenario B is favorable to only the richest quintile. We also saw that the effects on economic growth are greater in this scenario. It means that it's depressed more the economy in the long run. The trade-off between economic inequality and economic growth is higher in this scenario. And also because we're increasing the progressivity also in labor, it leads to a smaller offer of labor supply in the long run. So this reflects on the output decrease here in the long run. So summarizing, we can say that the effects of this scenario here takes long to manifest itself on the case of the inequality, and also leads to a milder effect on redistribution. The conclusions here, we have showed the economy is converged to equilibrium, a degenerate equilibrium, non-degenerate equilibrium, in this model with the intertemporal substitution as a source of heterogeneity, which means that if you're using the progressive taxation, we will have at the long run a non-degenerate distribution. Also, we show that the switching to a flat tax rates on labor income, it's a good policy to avoid the Great Depression in outputs in the long run, and also has stronger effects in terms of redistribution. But we're also showing this model that in both models that there is a trade-off between economic growth and inequality. So the policymakers have to bear that in mind when they are implementing increasing progressivity, especially when they're trying to divide this tax on the labor income, which has stronger negative effects on outputs. So just talking about the future research on this area, we are also working a model that it's very similar to this one, but investigate the effects of the Trump tax cuts in 2017 in the United States. So we have to work more in the calibration to have a benchmark distribution that is more similar to the US distribution. And also showing the effects to the 5 quintiles as we are showing here, try to mimic the reality as happened in the United States economy after the implementation of this taxation methodology. So thank you very much for all. If you have any questions, I would like to try to answer them.
Thank you, Fernando, for the great presentation. Now I open the floor for questions. If you have one, just unmute yourself and ask any question. So I have one.
Okay.
Unfortunately, my internet turned off twice here because of the rain now in São Paulo, and I lost a part of our presentation. But I have one question on the beginning of the presentation. Just what is the motivation to choose the complete market economy? Because you show there is these branches of the literature with complete and incomplete market. So what's the motivation of choosing the complete market economy in your work?
Yeah, we choose this model, this framework, because we're following Konyuk and Chernovsky, but actually the approach is quite different here, and we're looking for how change affects all the aggregate economy, not only a specific group. So yeah, it's a very interesting approach to using complete markets too. It's for the extension we like to provide here. But in this model, we're looking for the effects of fiscal policy that affects the whole economy as a set, you know. But you're right, it will be great to extend this model and actually compare the both models, both results in a complete market and incomplete markets. It's not too easy to do that, but it's for the research that we are trying to do.
Okay, thank you.
You're welcome.
Any other question?
Oh, thank you, guys. If you don't have any questions, if you have further questions, you can send me an email or anything like this. You can keep in touch. And I will be glad to answer the questions and receive comments and critics, everything.
Okay, thank you.
Thank you, guys.
So I will share my screen now. Are you guys seeing my presentation? Yes, okay, thank you. So hi everyone. First of all, thank you again for being connected today, for the opportunity to present my work for this audience. So my paper is Ambiguity, Business Cycle and Wealth Inequality. This is a paper that is part of my PhD thesis at INSPER. And the standard way to treat expectations in macroeconomic models is to assume the rational expectation hypothesis. Under this assumption, the economic agent perfectly knows the objective probability governing the evolution of the state variables of the economy. However, it requires a high level of sophistication of the agents and faces serious difficulties when confronted with experimental evidence and data. The notion that ambiguity affects choices of economic agents has gained currency in the recent literature. So in these papers, we focus on less demanding assumptions, in particular expectations characterized by ambiguity. So as I said, in this paper, we relax the rational expectation hypothesis and simulate an incomplete market economy populated by infinitely lived agents. The economy is subjected to shocks on the total factor productivity following Crusoe and Smith. And ambiguity arises from inferring the true probability distribution behind the evolution of the TFP shocks. The idiosyncratic shocks are calibrated to match the income dispersion of the data because this is an important channel that connects the uncertainty about the TFP and the income fluctuations. The agents are sensitive to ambiguity and their preferences are represented by the smooth ambiguity model of Ribanov, Marinacci, and Mukherjee. We adopt a specification of the smooth ambiguity model that allows for wealth decreasing absolute ambiguity aversion. So formally, the agent is less averse to ambiguity at higher levels of wealth. For instance, Bailon and Plácido provides recent empirical evidence in support of that. So the objective of these papers is to study the implications of the introduction of this additional layer of uncertainty on the wealth distribution, the degree of partial insurance in the economy, the behavior of aggregate macroeconomic variables, and business cycle fluctuations. Now, I will introduce the model. So as I said, the economy is populated by a large number of infinitely lived consumers. And as I said, there are two sources of uncertainty in the economy, the TFP shocks on the aggregate level and the idiosyncratic labor productivity shock on the individual level. The two shocks are correlated And the agent does not know the probability distribution behind the first type of uncertainty, so the aggregate shock, and they know for the second type. So they know the probability distribution behind the individual, the idiosyncratic labor productivity shocks, but since this idiosyncratic shock is correlated with the aggregate shock, there is also an uncertainty for the individual shock. Okay. So the individual chooses how much to consume and how much to save each period. The state space is composed by the individual asset, the idiosyncratic labor productivity shock, that is composed by two components, the transitory and a persistent component, and the TFP and the aggregate capital and labor. The agent does not know the stochastic process governing the evolution of the aggregate shock, and this uncertainty is indexed by the parameter theta. So for each theta, there is a probabilistic model associated and denoted by P of theta. And for each P of theta, the agent has a prior mu, okay? So the agent has a prior mu for each probabilistic scenario. So the preference is represented by the recursive smooth ambiguity function. So, and as you can see here, the first term is the instantaneous utility that depends on the consumption at the t, plus a discounted continuation value. The term expected utility with respect to pi of theta here is the expected value for each probabilistic model the agent has in mind. I call this the first order uncertainty. And this second term here, the expected utility with respect to mu, is the expected value considering all models with weights given by mu. So for each P of theta, there is a mu associated, and then you compute the expected utility using this mu. And I call this the second order uncertainty. And the function phi applies to this second expected utility, okay? So, U is an increasing function, phi captures a version with respect to the second order uncertainty, theta captures the size of ambiguity, V of theta is the continuation value, and beta is the subjective discounted factor. So, as I said, perceived ambiguity is characterized by properties of the set theta, and attitudes towards ambiguity is described by the shape of phi. Attitudes towards poor risk depends only on the shape of U. We choose one possible specification for U and phi that exhibit wealth decreasing absolute ambiguity aversion, which is the power utility for U where gamma goes to 0. So it's approximately risk neutral. Okay, so, and the phi is the log. So recall that our agent exhibit wealth decreasing absolute ambiguity aversion if ambiguity aversion is higher at lower levels of wealth. On the firms, there is a representative firm that hands capital and labor from households to produce the final good. We follow the standard Cobb-Douglas production function with constant returns to scale, and ZT is the TFP. Realizations of ZT is observed and common knowledge among the agents in the economy. The price follows the first order condition of the firm, where R is the return on capital and W is the wage paid per efficient unit. In order to optimize, the agent has to forecast prices, and we adopt the following two laws of motion for aggregate capital and labor following Crusoe-Smith. So note that the coefficients of this law of motions depends on the states of the economy ZT. And we assume that ZT follows a first order Markov-Chain process with two states, expansion or recession, and a transition probability given by lambda DGP, which is the true data generating process. And as I said, the agent does not know the lambda DGP, but they have we assume that all agents share the same two possible models about the evolution of the TFP. One that we call optimistic and the other pessimistic. So theta GGP is the probability of transition from an expansion state at the T to an expansion next period. And theta optimistic, we take theta GDP plus epsilon. And epsilon is a parameter that governs the size of ambiguity. So in the good scenario, the probability for a transition to an expansion state is overestimated. And in the pessimistic scenario, the probability to transition to a recession state is overestimated. Okay, and epsilon is the size of this ambiguity. Now we consider three different rules for the belief formation, mu. So mu is the probability that the agent is the belief that the agent assigned to the optimistic scenario. First, we consider the standard Bayes rule. And since all individuals observe the same realization of the TFP each period, any difference on mu among them asymptotically vanishes as they learn. However, in situations where learning is costly or individual is influenced by psychological factors, when making decisions should suggest the persistence of heterogeneous beliefs. And then we consider two additional rules.
Hi, Anna. Can I ask you a question, please?
Yes, sure.
So could you go back to the previous slide?
Mm-hmm.
So let me see if I understand here. So I thought that individuals observe their own idiosyncratic shock, correct? And the idiosyncratic shock is correlated with the aggregate state of the economy.
Yes.
So why shouldn't the idiosyncratic shock, their own realization of the idiosyncratic shock appear in their Bayes rules? Because it provides additional information, right? If I see that I receive a negative shock,
mm-hmm.
I have a higher probability to be in a negative state.
Sorry, the agents observe Z, so they know the TFP, so they know Z. They
Sure.
all observe Z. Okay, what they don't know is the probabilities. So if he observe a recession, for example, and if he receive a bad labor productivity shock, he know if it's a recession or an expansion.
Correct.
Right?
They do not know the distribution. That's the distribution. The distribution of Z's. Okay, so that doesn't mean that knowing my own idiosyncratic shock does not provide any information regarding the distribution, the aggregate distribution of Z's. Is that so?
Yes.
Okay.
So their own realization of the idiosyncratic shock does not give additional information about the distribution of the TFP. Yes.
Okay. Thank you.
Okay, thank you. So continue, we consider two different rules. One we call second order optimistic. So it imposes a positive correlation between the current labor income and an overestimation of the transition probability to a favorable state. So the higher the labor income the individual receives at period T, the more weight he puts on the good scenarios. That is, the model that overestimates the transition probability to an expansion state. So their own labor income or their own labor productivity shock does not give additional information about the true probability distribution behind the TFP. But in this rule here, we assume that if he receives a good shocks, he give more. Actually, it's not on the shock, but on the labor income. So if he receives good shocks for consecutive periods and have a high labor income, so he gives more weight to the optimistic scenario. Okay. And in the second order pessimistic rule, this correlation is negative, okay? Note that our construction of belief for these two rules allow for an agent to change his view or his degree of second order optimism or pessimism each period in a heterogeneous way, even though they all observe the same data. Okay. So recall that the individuals are ex ante identical. They face the same stochastic process, but they are ex post heterogeneous because each of them receive a different sequence of realization of the shocks. There is a mean zero transitory labor productivity shock and a persistent shock that is a mixture of normal. So we follow Gouvenin and other authors who find that during recessions, large upward earnings movements becomes less likely, whereas large drops in earnings become more likely. Okay. So you choose this specification for the income shock, for the labor income shocks to better match the distribution of income. We assume that all agents are not allowed to contract debt at any time, and individual budget constraint is given by, so they consume and decide how much to save for the next period. And there is the return on capital minus the depreciation plus the labor income, which is given by the wage times the labor productivity, which is the sum of the transitory shock plus the persistent shock, times 1/3, which is a normalization for the labor income. We define a recursive equilibrium in the standard way, so agents maximize utility subjected to the budget constraint, firms maximize profit, and markets clear, basically that. We calibrate the TFP shock, the production function, and the firm, and the transitory shock as in Khrushchev-Smith. The parameters for the preference follow Serreira, Vioglio, and other authors. So as I said, gamma is approximately 0. So we choose 0.01. And the process for the persistent labor productivity shock, we follow Gouvenin and other authors and calibrate the mean of the normal distributions to match the Gini income of the data. So in the first column is the data. The second column is the Khrushchev-Smith model. The third column is the Khrushchev-Smith, the third column is the Khrushchev-Smith model, but we substitute their unemployment shock by the process of the labor productivity shock that we use here in this paper with a mixture of normals. And we can see here that the Gini income goes from 0.07 to 0.51, which is consistent with the data. Okay, so basically, and this reflects in a more unequal wealth distribution. And here in this fourth column is here we consider epsilon equals 0. So the optimistic scenario is equal to the pessimistic scenario, which is equal to the true data generated process. So there is no ambiguity here, but what changes from here to here is the utility. Here we consider our smooth ambiguity model with wealth decreasing absolute ambiguity aversion. And as we saw in the previous slide, is in the utility part is approximately linear. So here we have risk aversion, and here we have approximately risk neutrality. And then the Gini index remains the same, but the wealth Gini falls, okay, because there is no risk aversion here. And here in the last three columns, we have the three different beliefs for the models. The first is the base rule, the optimistic, and the pessimistic. And we can see here that the optimistic scenario, the wealth is the same, but for the pessimistic rule, the Gini index increases 7 basis points. Okay. note that here the fee is the individual's investment rate relative to total income. And if you compare here with the model with no ambiguity, here the investment rate decrease for the pessimistic belief formation rule, and phi are the insurance coefficients for the persistence shock and for the transitory shock. And as we can see here, the insurance coefficient for the transitory shock remains stable in all models and consistent with the data. And for the persistent shock, it remains approximately 0.65, okay, among all models. And another feature of the model is if you compare the model with no ambiguity and the model with ambiguity, we can see that in all cases, we find more dispersion on aggregate consumption and aggregate investment. The correlation between consumption and output decreases here, especially if you compare with this model here with risk aversion, with only risk aversion, and here we have the ambiguity aversion, but the risk part, the agent is risk neutral. And the correlation between the interest rate and output decreases, which it's negative, and the correlation on wages with respect to output increases. Okay. So to summarize the results, we find the Gini coefficient for the wealth increases 3 basis points for the base rule and 7 basis points for the second order pessimistic belief rule, and no impact for the second order optimistic rule. In all cases, we find more dispersion in aggregate consumption and investment. The correlation between consumption and output decrease, the correlation between interest rate and output decrease, the correlation between wages and output increase, and the dispersion of interest rate decreases. None of the models successfully explain the amount of money the top earners in the wealth distribution hold. And in the paper, we also construct a sensitivity analysis that does not confirm the implications on the wealth distribution. That is, the Gini coefficient for a model assuming the rational expectation model is equal to a model that relaxes this assumption in the specifications that we consider in the sensitivity analysis. Hence, model that consider both risk and ambiguity aversion, the former dominates the latter, and there is no impact on the wealth inequality. The implication on aggregate macroeconomic variables are missed, because in the sensitivity analysis, we also allow for risk aversion and ambiguity aversion, okay? Because in the benchmark scenario that I presented here, the agent is risk neutral and its wealth decreasing absolute ambiguity aversion. But when we allow for risk aversion and ambiguity aversion, the risk aversion dominates the ambiguity aversion, and the impact on the wealth inequality it's not robust. Okay, so that's it for today. Thank you all. If you have any question, I would be glad to answer.
Okay, let me ask you one question then. And I was, how important is, we know that those Krustal-Smith model in general, incomplete market models have trouble generating this top income inequality, top wealth inequality, sorry. And use a fancy income process, well, at least a mixture with a very negative skewness, right? And that's in principle generate additional precautionary savings in absence of ambiguity or anything like this. So I wonder whether you use a much simpler income process, even a Krustal-Smith, just to state whether that improvement would be so large from the traditional Krustal-Smith model to just a traditional Krustal-Smith model, but with this simple income process instead of just a very with this skewness shock that you have in the typical governance process. So yeah, go ahead. Sorry.
Go ahead. So you are asking if I relax the rational expectation hypothesis in the Khrushchev-Smith model, how the dispersion of wealth goes. Is that right?
but maintaining a very simple income process, right? Even the typical one that you use in the Khrushchev-Smith original paper.
Yeah, so I did that in the beginning when I started in this paper. So I take exactly Khrushchev-Smith and I just relax the rational expectation hypothesis and put this framework with ambiguity, with smooth ambiguity, and the impact is very small because the income is not so dispersed, because the Gini income is so low that the effect that they don't know the true evolution of how the TFP evolved does not matter for their precautionary savings. Okay,
I see.
So that's why I incorporate a more realistic income process, because the interaction between the income and the income shock and the aggregate shock, this interaction is relevant, becomes relevant, okay, for the precautionary saving, because the fact that the agent does not know the TFP effect, that they does not know how their own shock evolves, and then creates an additional precautionary saving motive. But as I show here, this result it's not robust when I consider both risk aversion and ambiguity aversion, because the risk aversion part is more important for the precautionary savings. Okay.
I see. No, I understand. I have a better sense now that the income, it's very important, of course. Now, I have an additional question. This is, sorry, by my own, I mean, I know nothing about ambiguity in general. So does that matter that we are in a Khrushchev-Smith economy, or could I just model, let's say, some sort of ambiguity, but in the idiosyncratic shock instead, and solve the model for the steady state? I'm not even sure whether it's tractable or if that's possible to do it. But does that matter if that shock is aggregate? Could I do this in just in the idiosyncratic shock instead?
I didn't do that. It's actually an interesting idea. In principle, I think it's possible to do that. When we introduce the aggregate shock, the model becomes more difficult to solve. But if we consider a model with no aggregate shock and just uncertainty and ambiguity in their own shock, their idiosyncratic shock, I think this is an interesting idea to explore how the results might change.
Yeah. Okay. So maybe just two suggestions. So there's Government has a paper where there is learning your own income process. So this is I mean I don't know whether this could be related to your own work. And the second one is it's just that my comment, it just because wealth is something that does not change over the business cycle, right? So wealth is something that is built up over time. So, I mean, introducing ambiguity over the business cycle or in the idiosyncratic shock, who knows whether it would make a difference or not. I think for wealth distribution, the steady state should be fine. But okay, thank you.
Thank you. Thank you for the comments and for the suggestions. Any other question? Okay, so thank you all for attending this session today. So I think we could finish. And thank you, everyone. Bye.
Obrigado aos apresentadores. Vou encerrar essa sessão então.